Okay, so welcome back. Today we are moving with problem 486, that is predict the winner. This was the problem which we have already solved yesterday. Uh, Today's problem is the stone game. I have shown you this particular problem, that is predict the winner, because it is almost everything or same as it is in this solution. You can also check the solutions, and that is not an issue. 877 stone game. What is basically, as in this particular predict the winner, what we had is two players, player one, player two. So here we have Alice and Bob, and they particularly has an array named piles, and that particular array has, like, at each index we have the number of stones. And so at last, what is the goal is to like, we have to maximize the number of stones we have, and at last the person with more stones wins. And one more addition is Alice and Bob are play optimally, because like they are equal optimal or equally clever, so there is no issue. And let's we have to return true if Alice wins, and we have to return false if Bob wins. Additional detail is Alice will start the game. Alice starting first. So let's look at the first test case. What we have, we either pick the first or the last one. You might go with any. Let's consider like Alice picked the first. So this is the resultant array that will be passed to the to Bob. So from this, Bob can either pick 3 or 5. So let's consider Bob picks 5. Then this is the resultant array that is passed to Alice. Now in this, Alice can either pick 3 or 4. So Alice moves with 4, and her total profit become, like, total number of stones become 9, and the total number of stones with Bob are 5, like 5 plus 3. This is 8. So basically Alice wins, so we have to return true. Let's come to the next test case. Here, Alice will pick first. Consider anything. If she picks the first one, then Bob will have the this as the resultant array, that is 7, 2, and 3. From this, Bob can pick 7 and he can win. So what Alice should do? She is she should basically go with the this 3. So this will be the resultant array that will be passed to Bob. Now in this particular case, Bob can either pick 3 or 2. Bob, any of this, like either he pick 3 or either he pick 2. 7, like let's consider he picks 3. 7, 2 is the array that is handed over back to Alice, and from this Alice can pick 7, and that's how Alice score becomes 10 and Bob's scores become 5. Alice wins, so we have to return true. So like this was the whole intuition and about the test case. Let's move to the solution part. Here we have solution. Let's first consider n as the size of piles array, then making a two-dimensional vector named dp, where we use dynamic programming and reduce the computation every time. Like we will not compute everything every time. If it is pre-computed, we directly use it. That's the part of dp. Then we have in, like, we store the result from this particular function, and just at last we check that is the result greater than equal to 0. I will explain when I will explain you this calculate. Let's move to calculate. So what are the inputs that calculate has? That is, first is the piles, that is basic the need which has been input. So I have been passed it by address because we will not copy this every time, and that will reduce our time complexity as compared to copying it every time or for each loop. Then we have start and end. This basically is used as when Alice picks 5, this is the resultant array, that is 3, 4, 5. So in this case, we have to create a start pointer and end pointer showing that what is the remaining resultant array. So that is used in the same case. So here, where it was is here. So start and end, and then we use the same DP which was provided above, using it by address because we will make changes and we have to reflect those changes actually. So first is if start equal to end, and what we have to do is, see, let's consider this case. Alice picks 5, so this is the resultant array 3, 4, 5. From this 5 is picked. Now 3, 4 is remaining. Now if 4 is picked, last is 3. So in this case, only 3 is the resultant array or last. So this is the case where start and end will point at 3. In that case, what we have to do, return piles of start or end because both are equal. Return any of them. That will make the thing work. And if like it is not equal to int minimum, as we have initialized the whole DP with int minimum, all the elements will be int minimum. If we have calculated anything, then basically that will be like if it is computed, then we will return it is if it is already computed, we will return it. If it is not, we will go pick the left, pick right, and we will check where we get maximum number of stones, and then we return that. So it's like picking left is we have this, so the whole array, here we pick 5, so this is the resultant, right? So what we do is picking this 5 and then minus, and this is the array which is handed over to Bob, let's say. So when Bob has this particular array, what Bob will do, like he has to pick one from it. So we compute that the difference from that, and at last picking right, same logic that if Alice picks this, this is the resultant array, and Bob will pick. So we subtract the difference of them. So basically, what we I have done is using maximum of this because we have to maximize the number of stones with us, and at last we are returning that. So what will happen? I will check the difference in Alice number of stones and Bob number of stones. So if the difference, like if Alice has greater number of stones, then basically the difference will be greater than equal to 0. So I have basically returned greater than equal to 0. So as when we will return greater than equal to 0, if it is, that will return true, either else it will return false. Simple logic in this case, and this code runs and it like runs well, no issues. So this was the total code intuition of 877 the stone game. So that's it. Thank you for watching, and be consistent and understand the code intuition. Thank you.